once you get the motor mounts in place, put a wrench on the end bolt again and spin it over carefully just to make sure that nothing has shifted during the assembly process, that the rotor is not touching the stator. Incidentally, earlier when I cranked it over to listen, there was a squeaking sound. This was not caused by mechanical interference. It's caused by the fact that I was spinning the motor backwards, which keeps that bolt tight. And when you spin the motor backwards, you're hearing a squeak of air coming backwards through the intake. Kind of like a reed valve. Whenever the valves start to close and it's forcing air backwards out through it. So don't let that noise upset you if you're cranking it over. Okay, to begin the assembly process, the first thing that I put in is going to be the brushes. The brushes bolt to these two bolts right here, and they ride against these two slip rings. I'm using a little electrical contact cleaner on the slip rings themselves, just to make sure that I get any cosmoline off that was left on during the shipping process. And also because it smells so nice. This is a brush holder. These are the brushes. They're held out with spring tension. If you're changing a stator, check the brush length specification against the service manual. Incidentally, if your motor has never been apart, the brushes are originally held on with 12mm long bolts. I use 14mm long bolts because they do not bottom out in the hole, and they're just a little bit longer. Keep in mind that the brushes ride against those slip rings, and if this brush holder were to come loose, it would be very destructive. Now you can see the brush holder is in place. Next thing I'll put in is a voltage regulator. Voltage regulator, you're perfectly safe using the shorter 12mm long bolts. The voltage regulator uses a plastic case, and neither one of the terminals on the case are bonded to the ground. In fact, you can check that by completely removing the voltage regulator mount bolts and running the generator, and it makes no difference. Do not over tighten the bolts. You don't want to strip the threads. There's no point in that. This is a capacitor. It's used to regulate. Before you put them in, if you're putting together a used one, check these wires and make sure that they haven't corroded. For some reason, they have a tendency to corrode and pop loose. Sometimes the trauma of disassembly and reassembly is all it needs to make them come loose. I try to spin the capacitor to where the leads are facing straight down. They naturally want to face straight out at you, but if they do, then they will rub against the outer casing when you put them together. These two wires go to the brush holder. Keep in mind that the screw and the star washer that hold these wires to the brush holder are both stainless steel, so they are not magnetic. If you drop one, you cannot pick it up with a magnet. You've actually got to find it. So be very careful. That's the star washer, which, excuse me, is brass, and the screw, which is stainless steel. At any rate, neither one is magnetic. If you do inadvertently put these wires on the wrong post, and by that I mean white on red and red on white, the generator will still work. The only reason why it's done this way is for troubleshooting purposes. If you're using an oscilloscope and you want to check the phase, if you put them on backwards, it'll just be 180 degrees out of phase on the rotor. But the generator will still put out, because every magnet still has a north pole and a south pole. They've just switched positions. When you stop to consider the rotor spins anyway, it phase shifts twice per revolution. Okay, next will be the diode. And this diode rectifies subwinding number 2 for the cooling pan. If you're replacing a stator, make certain to check this diode before you reassemble it. Testing the diode is really quite simple. You can either do it with a simple multimeter on a resistance scale, or if you have a diode test scale on a nice meter, you can do it that way. I'm going to demonstrate it with a Fluke 88, but I'm going to use the simple resistance scale because just about every meter has that. Take the black meter lead, put it against the single post. Take the red, put it against one. You've got infinite resistance. Put it against the other. Notice on the meter you've got infinite resistance. If you were to touch the two meter leads together, then you would see the resistance drop. Then put the red on the single post and the black on one of the other posts. Got 1.88 meg. Move the black meter lead to the other post. Got 1.951 meg. As long as your two readings are within 10% of each other, I'm happy with it. Depending on the internal resistance of the meter, whether it's like 10,000 ohms per volt, or in this case it's 50 million ohms per volt, so says Fluke Instruments. As long as the two readings are within 10% of each other, you're good. So we had 1.9 something versus 1.8 something, which is well within. If it doesn't show good, replace this diode. If you don't replace the diode and it's shorted, you're going to burn out subwinding number 2 in another stator. So you save $40 on a diode and burned up an $800 stator. Okay, that's probably as good a place as any. Take a break.